TED Talk with Morgan Watson. The Cardio and Respiratory Systems by Megan, Aaliyah, Gavin, and Morgan Watson. The cardiovascular system is a closed system which incorporates the heart, which pumps blood, and the blood vessels, which allow blood to circulate throughout the body. The primary function of the cardiovascular system, which is imaged in this illustration below, is to deliver oxygen and nutrients to the body, but also remove carbon dioxide and other waste.
Whoa. Oxygenating the cells.
The cardiac cycle and sounds. Diastole. The heart relaxes in the chambers, bum, 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 bum. Atria and ventricles fill with blood. Next, the atria contracts and pushes blood into the ventricles. Opposite to diastole, you have systole, where the ventricles contract and push blood into the arteries, aorta and pulmonary artery to be specific. Atrioventricular valves close to prevent backflow. You don't want backflow. No, you don't. And then finally, semilunar valves open and allow blood to flow back into the arteries. Boom, boom. Without this cycle, you wouldn't be able to survive. Valves function primarily as the AV valves, mitral and tricuspid valve, close during ventricular contraction, which is very important in preventing any irregularities in heartbeat patterns. Semilunar valves open to the ventricles is also something you must consider. To go deeper, the lub sound is the closing of the AV valves. Lub, and then you have dub. Lub, dub. Lub, dub. The dub is the closing of the semilunar valves. Lub, dub. Lub, dub. Lub, dub. As seen here.
Wow.
Shall we?
The respiratory system. Carbon dioxide, or CO2, and O2 overseas gas exchange. Between blood and external environment, organs such as the nose, pharynx, larynx, trachea, bronchi, lungs, or the alveoli, parts of the lung. Air enters through the larynx, which is demonstrated on this beautiful respiratory system model. And then, which, by the way, the larynx allows passage of air and prevents other things from entering, like food. Then travels down the trachea, the main airway to the lungs, where in the lungs the air reaches the alveoli while oxygen enters the blood and carbon dioxide is removed. Finally, the diaphragm contracts to pull air into the lungs. Contraction of the diaphragm. Air enters the lungs, goes down the larynx into the lung. Each alveoli fills with oxygen, which diffuses into the bloodstream due to property of diffusion, and then carbon dioxide, which is rich in the bloodstream prior 2, diffusion, goes back into the lungs, you breathe out carbon dioxide, and you repeat the process. Wow. How they function together to maintain homeostasis. Not hetero, but homeo. First, they work together to ensure the delivery of O2 and the removal of CO2. Oxygen enters the lungs and diffuses into the capillaries, where it's picked up by blood for delivery to tissues. And that is most important. You must always remember that. Arterioles help regulate blood flow and pressure as oxygen-rich blood travels to body tissues. Your brain needs it, your feet need it, your fingers need it, my lips need it. Very important. After oxygen is delivered, venules collect carbon dioxide-rich blood and carry it towards the heart, as I mentioned earlier. Oxygen is used during the respiratory processes and creation of ATP on the cellular level. That's just a little bit deeper information for you. And then you end up with all this extra CO2 as a waste product. It's got to go somewhere. The vena cava transport deoxygenated blood back into the heart, which sends it to the lungs to remove CO2 and restore oxygen levels. Breathe in, diffuse oxygen in, diffuse CO2 out, breathe out. Blood and oxygen importance for homeostasis. Oxygen delivery, number 1, oxygen carried by the blood cells allows cells to carry out cellular respiration to produce ATP, as I said earlier, through multiple means. Next, carbon dioxide removal. Blood removes CO2 or carbon dioxide to prevent toxicity in the blood. As I also mentioned earlier, it is toxic. You can't have that. CO2 is actually very acidic and it will raise the acidity within your blood. You got to maintain homeostasis. How do you do that? Through this process. Next, nutrient transport. Blood carries glucose, amino acids, and other nutrients for cellular repair. You need a lot of things, and where are you going to get them? On the highway of your body, which is your circulatory system. Next, temperature regulation. Blood helps to distribute heat through the body. Blood's warm. It's your HVAC system. Pump, pump, pump. Keep that cool 98 degrees going. Hormone transport. Blood delivers hormones all throughout the body. That incorporates a little bit of your endocrine system. But testosterone, estrogen for my girls out there. You need to get your hormones somewhere. Your blood, you can pay for that. Next, immune defense. While white blood cells and antibodies travel in the bloodstream to fight off infection, the big, nasty protectors of the world, your white blood cells, they're mean, but they're on your side. We are ever thankful for that. Finally, waste removal. Well, waste products are carried by the bloodstream to organs like kidneys for excretion. That's an incorporation of your digestive or waste or system. You gotta get rid of that pee somehow, that urine, if you will. And how do you start that process? Your circulatory system. Anatomy breakdown. We're almost there, people. Stay with me. Deoxygenated blood enters the right atrium. Our atria for short. We'll reference it as that. Through the vena cava. Remember that, people. Vena cava. If it then passes through the tricuspid valve into the right ventricle. From there, it is pumped into the pulmonary artery veins. Pump, 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 pump. Going through the pulmonary semilunar valve to reach the lungs. Receiving oxygen. Oxygenated blood returns to the left atrium. Boom, boom, boom. Left atria. Passes through the bicuspid valve into the left ventricle. and is then pumped out through the aorta, passing through the aortic semilunar valve to the rest of the body via arteries, arterioles, and capillaries. The right and left coronary arteries supply blood to the heart muscle itself, which is important because, the pump itself also has to work. And the carotid artery carries blood to the brain. Venules collect blood from the capillaries and return it to the veins. That is one of the most important points, and we must remember that, especially when covering the circulatory system. Physiology breakdown. Diaphragm, muscles that separate the chest from the abdomen and helps in breathing. Next, we're going to power through this one. Alveoli, tiny air sacs in the lung where oxygen and carbon dioxide are exchanged. We've already covered that. Physiology. Well, it is a study of how the body functions. Remember, functions related to structure, people. Always remember that. Conduction system of the heart, the network of nodes, cells, and signals that control the heart's rhythm. Say it with me. Love-dub, love-dub, love-dub. The cardiac cycle, the sequence of events that occur during one complete heartbeat. Say it with me. Love-dub, love-dub, love-dub. 3 times only. External respiration, the exchange of oxygen and carbon dioxide between the lungs and bloodstream. All right, next. Please keep it down to a minimum, the chatter. Blood pressure, the force of blood pushing against the walls of the arteries. You eat too much Taco Bell, that blood pressure is going up, so watch out. Inhalation and exhalation, the process of breathing in and out. Internal respiration, capillary. Well, that is the exchange of oxygen and carbon dioxide between the blood and the body cells. Micro level. You have to look at a microscope to understand that part.
Come here.
That is it. And I want to thank Megan Hess for directing. I want to thank Gavin Westra for providing great slides. And I want to thank Aaliyah for being the DOP, Director of Photography. Thank you. TED Talk out. This has been Morgan Watson's TED Talk, and I want to thank you once again for your time. I hope it was up to satisfaction. Did you enjoy it?
I had a great time listening.